In this video, I'm going to overhaul an old Stromberg Carlson model 58L. This is a 1936 AM and shortwave radio. It features two 6D6, a 6A7, a 75, a 42, and an 80 rectifier tube. And this radio is going to require a total overhaul of all of the electrolytic and the paper condensers because they're no good. They got to go. So I have here an old Stromberg Carlson AM shortwave receiver. As you can see from the dial there, it covers from about 540 kilocycles, I guess it is, all the way down to 1.5 megahertz, and then again on the shortwave band from 1.5 megahertz up to about 3.5, and then the third band 5.6 right through to 18 megacycles. So it'll cover the 80 meter band, cover the 160 band, and the 80 meter band. It also cover the 49 meters down through 16 meters. Of course, this is an AM receiver, very old. I found this and picked this up really quite reasonably. Cabinet's actually in not bad shape. Check this thing out. I guess I'm as wide as my camera will go. This is a fairly good sized radio. It stands about 3 feet tall, and we're going to restore this thing. One thing to note on radios of this vintage is that the speaker itself does not have a permanent magnet. It actually has a coil of wire around the back, and high voltage DC is placed through the coil of wire. This produces your magnetic field for the voice coil. The voice coil, of course, this is the audio output transformer. The voice coil is being driven from the audio output transformer. Magnet is produced through here. This also has a secondary effect as it operates as a humbucking choke to reduce AC hum on a lot of these old radios. Let's take a look at the chassis. Now, like a lot of the old radios of the day, 455 kilocycles is the standard IF frequency for modern AM radios. This one used 465 kilocycle IF. Here's the tubes that are in this radio. If we look at the tube chart here, it uses a 6D6 RF tube and a 6A7 mixer, 6D6 IF amp, 75 demodulator, a type 42 audio output, and a type 80 rectifier tube. So it's a 6 tube radio, and these are these big beautiful old tubes, and I have a box full of old tubes, so hopefully if any of these are bad I have some spares. I'm not anticipating that it's going to have bad tubes in it, but you never know, right? But here's the rectifier tube, the audio output tube is here, and our demod tube is this one, right? And what's the other one? The IF amp is over here. Our mixer is back here, and there's a preamp further back. Now, radios of this vintage, you don't plug them in until you've replaced all the paper and probably the electrolytic capacitors too. It's just something you do because the age of this radio, the capacitors in here are going to be a lot of the old wax type paper capacitors. And the problem with those is that the paper itself becomes acidic over the years, and it basically turns the capacitor into a resistor. So when the capacitors go leaky, and I'm not referring to leaking electrolytic, but they go electrically leaky. So you'll have current leaking through the capacitors, which will draw excessive current and damage other components. This leakage current will cause the tubes to go into conduction, can cause the tubes to burn out, and in worst case scenarios can even burn out transformers. And when you're dealing with a radio of this vintage, tubes like this are very hard to come by. So you want to protect the tubes at all costs. Otherwise, you just have a wooden box. And even at a wooden box, it would look pretty good, but in reality, you want to have these things working. So before I do anything, I'm going to pull the chassis, and we're going to take a look at the capacitors and change out the ones that need to be changed. Of course, the first thing to do is to pull the knobs off. So the knobs just pull off here. They're made out of wood with metal inserts, and they've got these felt pads to prevent scratching. So even these were all handmade, work of art. This radio would have been made in Toronto. It's a Canadian radio. So there's the main dial. Now this one here is held on by a screw, so I actually have to remove that. This is for the band selector switch to select between the 3 different bands. So I have to remove a screw to take that one out. I'm turning on my bright light here so I can see what I'm doing. But to remove the radio from the cabinet, there's some bolts that go into the bottom. So we're just going to remove the bolts that hold the chassis in place. So the chassis should just lift straight out here, which it does. Now, oh, there's a light bulb in the front now. So here's the inner guts of the radio. As you can see, what I'm going to have to change is I'm going to have to change, at a minimum, these capacitors here. These have to go because they are going to be bad no matter what. That one's going to be changed for sure. That one for sure. That one. There's another one down here. That one. There's 3 more down here. And possibly these ones too. But for sure, these paper caps, they all have to go because they will be bad without any question. Now, a lot of these capacitors are actually marked Stromberg Carlson, right? They made their own capacitors in this radio. This is beautiful. You know, very simplistic. And I'm just going to replace them with standard Mylar type caps. That one there probably should be changed too. More likely. I'll have to change this one. But if nothing else, these paper caps have to go before I'll even try to power this thing up. So let's get started. You notice on this cap here, as they all say, made in Canada. So all the components for this thing were all domestic parts. That's back when we actually had a radio industry in Canada, where anything you bought was made here. You bought a radio, it was made in Canada. You bought a TV, well, TV followed radio, but they were made in Canada as well. Stromberg Carlson was one such company. Rogers Majestic was another. They were actually standard radio, but that was owned by Ted Rogers Sr., who was who's Ted Rogers Jr.'s dad, who of course is Rogers Cable and Rogers Wireless Cellular here in Canada, largest telecommunications company in the country. But they had their start in radio, and this is what they did. Now this one, I have a Rogers Majestic, but this is one of the many radios that were around of the day. This electrolytic's going to get changed out too. This big one here. This is a dual 8 microfarad 450 volt electrolytic. That one's being changed out, as is this other one, because these will be bad. But I'm just getting this little bypass cap in place first. Solder broke on that connector. We do that too. Oh well, we'll just replace it with a new cap. Okay, here I've placed 2 new electrolytic capacitors here. They're connected to the ground side. I'm going to transfer the wires over, these 2 wires to one, these 2 wires to the other, and that'll replace this electrolytic and get that one taken care of. So the first thing we'll do is we'll remove these 2 wires from one side of the electrolytic here, if I can. And they may unsolder nicely. I may have to just cut them and prep them again, but we'll see if they'll unsolder. Of course, I'm going to leave the original capacitor in place because I want it to physically look like original. So some guys will actually hollow them out and stuff new caps inside them, but you're not going to see this, so I'm just going to tack them on the bottom and leave the originals in place. The other one should come off just as easily. Others might be critical that I'm going to just tack these parts on in the bottom of the chassis and call it not professional, but this is my radio. I'm not selling it, so no one's going to see this but me.
There.
This way I can leave the original electrolytic cans in place so that from the outside the radio will look stock, but it'll have new wiring, new components. So we'll bring one side of this cap out of the way, bring it into place, and connect it up to these two wires that I just disconnected. Okay, there's one. The other wire here. We'll just wrap it around the terminal. Solder it on. Okay, that's the second wire. We'll do the same for the other side of this cap. So you can get these wires off without damaging them. Here's the other. These two wires, as well as this side of this cap, has to go to this second capacitor here. I'm going to bend these wires around the same time. Oops. Okay, so that's got the belt, the dual filter, and this one, the 0.01, has been replaced. Now I've got this other one down here to do as well. We'll deal with that one in a bit when we get these other paper caps taken care of first. This one here, what size is this other one here? This Mallory. So next is this 0.02600. I got a 0.022 630. I'm not showing on camera, but I actually have determined which is the foil side for all of these caps prior to inserting them. I cover that in another video, so I'm not going to cover it again in this one, but we use a scope to determine which side is the foil side. Another 0.02 goes between the antenna coil and the first IF. If If you wonder why there are segments missing here where parts just magically appear, and the reason why is because there's shots where my head's blocking what I'm doing. So there's no point in showing that. So if things seem to be jumping ahead, it's because you couldn't see what I was doing. And unfortunately, the way this unit is, I can't take it out of the chassis because of the speaker without removing the speaker. So it's in an awkward position to work on. The camera's over my shoulder, and there's times where I lean in front so that I can see what I'm doing. And in those cases, I'm going to cut that out, like right now. The 0.02. One down here. Some of these are hard to get at. This one down here shouldn't be too bad. Another 0.02. Even though there's lots of room in these units, some of these components are in kind of awkward places to get, the way that they've routed the wires and so forth. So you got to kind of pay attention to where they come out of and try to route the new component in the same location as the original one, because sometimes the dressing of the wires can affect, just through induction, can affect the performance of the unit itself. So you always try to get the replacement components in roughly the same physical location as the original one, just so you're not going to worry about detuning any circuits just due to capacitance and induction.
question I've got is this my little light duty iron here gonna have enough power to solder to this tab? Hopefully it will. Looks like we're okay. Okay, that's done. Got about 4 or 5 more to change. Hopefully I've got them all. And then we'll see what happens when I put power to it. Whether it's going to make any sound or whether it's going to go up in smoke. Looks like this one's been changed before, because there's a wire that somebody just cut off. Okay, that's that side, and the other side goes up to here. Yeah, that one's been changed before. No question about that. It's been changed. This one's a 0.1 at it's only 200 volts. turn the radio up on the other side, only to find out that there's 4 more of them in here that I didn't see when I had it sitting up the other direction. So I had to change these 4 plus 1 more down. Well, there's some more down on the around the volume control. Okay, that one went to that terminal right there. This side of it goes down here. You see these old condensers, capacitors, whatever you want to call them. This is how bad some of these old ones are. We're taking these old ones out. They are crumbling, as you can see. Literally, they are crumbling. So you can see the value on this one here. I got 2 down here that are a little harder to get at. One is right here. The other one's in behind here. I can tell just this one here is also deteriorated to the point where it's crumbling, as you'll see when it comes out. You can't see it probably from the angle that it's in behind this. If I can turn this a bit so you guys can see where it is, but it's right here. It goes between this tube socket pin here along with this resistor and ground, and this one here is really coming apart, this cap. Where has it gone to? I think it's going to ground. Both of them are going to ground. There's another one right behind it here. It's also going to ground. That one. Almost impossible to reach the stupid thing. Come on, break free. There is the old one. As you can see, we get a close-up of this thing. Right, the electrode's actually coming right out at the end. Whatever they put in this wax, I guess it's just failing. It's coming right out of this cap. What size is this one here? It's a 0.01. And then there's this other one that's next to it, which goes up to the same tube, but up to here. So 0.01. 0.01, here's one. There's one of them. I get the other one out of here as well. This other one, it comes up to this tube up here.
Now that green wire you see me moving there by my pliers, that's actually a capacitor, believe it or not. They just take two pieces of insulated wire and twist them together to a specified length, and it acts like a very low capacity capacitor, but that's what it is. That's part of the tuned circuit, is that two pieces of wire, insulated wire, that are twisted together.
Got another one down here. It's a tone control. Okay, I think I've got all the paper and electrolytics replaced. This one back here has been replaced by this one, and I just disconnected it. It was actually had a nut on top that held the wire in place, so I took that off and just soldered the positive terminal to the lug and then the other side to ground. I've replaced these two smaller caps over here. These are like 35 volt caps. I put 100 volt, 10 microfarad 100 I put in place of it. So I think I've got all of the paper caps. So I haven't done some of these other ones here, which may need to be done, but I've got all the critical ones that definitely needed to be done. They've been changed out. So I think what I'll do now is I'll just put the chassis back in the cabinet, and we'll power it up on the dim bulb current limiter and run it up slow in the Variac and see if we get any sound out of this beast. Okay, I'm going to start it up here. I've got the Variac set at about 55 volts. So that should bring everything up at about half voltage. Let's see whether we get anything when I turn on the power. We have a light that's lighting. Let's see if we get any sound. I don't know which is the volume and which is the tone, so we'll just crank it up here and see if anything comes to life as it warms up. Okay, I've turned the power up slowly to 110. I don't see any excessive current on the dim bulb tester. Our light is now at the proper brightness here. Just watching for any tube activity. I see tubes are starting to glow. No sound yet. Okay, now the troubleshooting has to begin. I see the filaments are warming up, but I don't hear anything. So we'll check to see if any B plus is coming up from the rectifier tube. We'll check our voltage going to the rectifier tube first. And we'll check our output from the rectifier tube and see if we're getting any B plus here coming up on our main filter caps right here. There's a choke coil over here too. I don't know what shape it's in. Well, let's just see if we get any B plus to start with. We got 425 volts B plus. How about on this side of the choke? So we got lots of voltage. Lots of voltage. These caps are rated at 450 volts. So we got lots of power here. So why do we not have... I got nothing on this side down here. So I guess I have to stress here that yeah, when you're working on tube radios, you got to really watch it because the voltage in these things is very high, and it's enough to well, it's enough to kill you if you stick your fingers where they don't belong. So the rectifier is working, the transformer is working. We have no sound. Interesting. I wonder if the audio output tube is any good. That's this guy here. This one down here. Now things get interesting. Well, as I continue to test here, I find that I've got my plate voltage to my output tube, which is right here, 423 volts. But if I go to all the other tubes, I should have a plate voltage on them, and I'm not getting any plate voltage on any of the other tubes. So I'm going to go dig up a schematic for this thing. We'll trace some electrons and see why it's not working. This gives you an idea how hazardous tube radios can be to work on. This thing's been off for almost 24 hours. And you can see that the capacitor here is still storing 125 volts. Okay, I had the probes reversed there, but you'll see that the B plus still sitting at 125 volts. So before we work on this thing, we got to make sure that we completely discharge any residual voltage that's stored in the capacitors. Otherwise, you get a nasty shock. Now we're down to 1 volt. So now I can poke into here. I think there's one, when I changed out this cap, I think there's one lead that I missed. So I'm just looking in here, got the schematic for it here. And there's an extra wire coming off here, and I'm just looking through here, and I think when I hooked up this cap, I missed one, and there's still one wire connected to this old electrolytic I disconnected. So it's going to dig into here, remove it, and connect it to this lead here. And that will hopefully get my B plus back to the entire radio, and it will work. We'll get in here close to see where I think I missed it. It's right in that red wire there, you see. That red wire is still connected to this old capacitor right there. So I gotta cut that one off. That's the one I missed. Okay, now I've connected the wire where it belongs. Let's power this thing up again and see whether we get any noise out of it this time. So once again, we'll still go through the big dim bulb tester. Dim bulb is glowing slightly orange, which means that we're drawing a little bit of power, but not much. As the tubes warm up, maybe we'll hear something on it this time. I don't know what band I'm on, so. Switch it over to the AM band.
It can be intractable. I suppose there are a lot of ways to look at it.
Gotta like it. It's fixed. Okay, let me put this thing back together. Controls need to be clean. I'm going to throw some contact cleaner in there, and then I'm going to put it together, put all the knobs back on it, and we'll take a look at this beauty now that it's been recapped. So get some cleaner in here to the tone control. That's the volume control, that one. This one's the tone control up here. And we'll also spray down the band selector switch. I'm just going to put the chassis in and we'll see how it sounds. We'll have to also get me a new power plug for this thing at a minimum. Probably wouldn't hurt to change this cord, although the cord doesn't look to be in bad shape. It's one of those fabric woven cords, so this is not something that I would leave plugged in. An old radio like this, the odd time I'm going to listen to it, I'd plug it in, listen to it, and then unplug it. I'm certainly not going to leave something like this that's this old connected to power when it's not being actually used. But the power cord doesn't look to be in bad shape. You know, I've seen some that the insulation is all, like, especially the ones with the rubber insulation. This is a woven, it's got rubber, but it's got fabric over it. So I'm not going to change that. I'll get a new plug for it because this one's a hazard. It's broken. But I'm not going to change the power cord, at least not at this point, because this thing's completely authentic, other than the fact that the caps have been renewed on it. At least the paper caps have. Anyway, let's mount this thing and finish this one up. Then I can get on to my other one, because I was at the ham radio flea market and I picked up a couple of other toys to work on. Got that radio, and I got a nice old Bakelite radio. I used to have one of these, very much like this, except for mine wasn't green. If it had been green, I probably would have kept it, but the one that I had, that I got when I was about, I don't know, probably 5 years old, was pink. I
couldn't have a pink Bakelite radio, or it was painted pink. Couldn't have that. So anyway, I had one almost identical to that. When I saw that one today at the swap meet, it's like, wow, I had a radio identical to that when I was a kid. In fact, when I took the first tube radio I took apart and just about electrocuted myself with was one of those. Now you see, sometimes in this business you have to actually improvise, because you see, one of the light bulbs on this radio was no good, and I don't have a light bulb with the same base of the same voltage, and I don't want to convert this over to LEDs because I want to try and keep this thing original. I don't feel like making a special trip in to get a stupid light bulb, but I do have a 6-volt bulb with a different base. So the idea is we're going to put this thing in here and solder it in there and hook it up to the base, and then I've got a new incandescent bulb. So to do that, I'm just going to solder a piece of wire onto the bottom of the bulb here that I can stick through the base, solder it down, and then solder it in. So that's what we're going to do. Just going to take a piece of wire and we'll solder it onto the contact on the bottom of the bulb here. Then I can fish that through the existing one that I already broke off. Tack it down to the base here. Like that. And hopefully it hasn't come off on the other side, but give it a tug. No, it hasn't. It's good. Now I'll clip off the excess wire. Or in this case, maybe just bridge it right over. Put the dial light back in, and now we have 2 working dial lights. Gotta like it. And I put the screws in the bottom. Put the knobs back on the unit. This one's got a retaining screw for this knob. And there's a felt spacer that goes in behind. This is to prevent any scratching. And this is the band selector. So the band selector goes on like that. Then the tuning dial, and these are keyed so they only go on one way. Tuning dial goes on. 2 more scratch preventers, little felt pads, to go to the volume and the tone controls. Let's plug this thing in and see how it sounds. My kilowatt meter on here. We'll see how much power this thing draws. Draws 51 watts when it first starts up. That bulb is not quite as bright, but oh well. I'll deal with that. I'll get another bulb for it at some point. As this thing warms up. There's my test transmitter. I want to see what this thing picks up. Now remember, I do not have an antenna on here, so let's see how sensitive this is. Where's the tuning?
With great people.
That's a lot of noise from devices in here like my TV that's running. I'm just going to hook an antenna wire up to it and see what it does. So let's just sweep the band here, the AM band. until I get to about 650. There's a weak station there. I have a piece of antenna wire about 5 feet long on it right now. 690.
One lane and really busy there. Back with more now.
730. 980.
Ensures this has been in the works for months as Beijing moves to deliver on previous promises.
All that noise that you're hearing here, that's what I have to put up with on an AM radio 24 hours a day, shortwave radio 24 hours a day. I'm unable to use my HF ham radio at all because I get that noise 24 hours a day, 7 days a week, 365 days a year. It is all caused by high frequency digital electronics interfering. And in the case, what's causing this is ADSL, because that right now is still the most popular internet system. And I have a bonded loop currently operating in my house, giving me my high-speed 75. I think it's high-speed 100 is what I've got now. But it's throws so much noise out. It is ridiculous, the amount of noise that is generated by that and other electronics around here. But ADSL is probably the biggest source of noise because, well, the drop wire is right out in front of my shop here. It's like literally the drop wire feeding in from the street is literally about 10 feet from where this antenna is. So yeah, it creates lots and lots and lots of noise on the AM band here. But fortunately, we're in the process of upgrading everything out here to fiber optic right to the house. So once fiber optic goes to the house, my AM reception will be superior to what it is today. Shouldn't have any more noise. Let's just see what the shortwave bands do on this thing. We actually might even pick something up. On the higher band, I'm getting some harmonics from my little transmitter that's, 10 feet from me. We're not getting as much noise now once I'm above 8 megahertz because the ADSL frequencies aren't used much. It's really the heaviest used band is what they call 8A, or is it 8B? 17A and 8B, that's what it is. So we're on a bonded 8B loop. And what that means is that the ADSL frequencies go from about 200 kilohertz up to about 8 megahertz. And people that are closer to the actual ports, they're on a profile called 17A, which goes right up to 17 megahertz. But I'm a little further out from the ports, so everybody on my street here is not going to be on a 17A profile. They're all on an 8B profile. So basically everything below 8 megahertz is completely annihilated. So 40 meter band, 80 meter band, and 160 is completely useless for me, but I can still work 20 meters and 10 meters and 12 meters and stuff because that's higher frequency. So let's see what I can hear here getting up into the 20 meter band. Probably nothing this time of day. Harmonic. Another harmonic. Lots of harmonics off this little transmitter I built. I would imagine when it starts to get a bit darker, I'll probably be able to get WWV down at 10. Sounds like it might be there coming in a bit. Yeah, WWV in the noise. Still a lot of static. Here we go. That antenna, by the way, is lying on the ground, so if I put it up in the air, it'll probably pick up a bit better. It's just a piece of wire lying on the ground. I raised the antenna up about 5 feet. I stuck it up against the siding of my house. As you can see, the dial is exactly on 10. So the dial is dead on. Signal's not very strong. We'll have to wait for the signal to get better. You can hear it in the background there, fading in and out. There you go, Stromberg Carlson. This one was a model, what was this thing? Model 58L. Here's all the old garbage ones that came out of here. It had a few of them in here. There's the pile of crap that came out of this one. Good for another 100 years. We'll catch you in the next one real soon. Bye for now.